Sorry about that, the computer just cut out. So, we're looking at example 11 on page 317. We did A, and we said A was 6 factorial. 3 factorial, which was 6. Then, let's pull this down first. We're still considering the letters of the word dad. In B, they want to know how many word arrangements can be made with this word if the repeated letters are treated as identical letters. Which means to say that this D here is the same as that D. So both these are the same. You guys understand? So what are my options? D, A, D. Not so? How else can I write this? Huh? A double D S or A D D and D D A. So how many ways are that? 3 ways. Why? Because the 2 D's are the same, they are identical. So when they do say that letters are identical, then we could have said, okay, this is going to be, since there are 3 letters, 3 ways, 3 factorial. How from 3 factorial will I end up with 3? If I have 2 factorial. Or, we can say the number of letters divided by the number of repeated letters. Can you see that? So, what the letters that are repeated are? The D. Not so? So, that would be 2 D's. So, that is why it's divided by 2 factorial. Okay. Let's carry on. Let's see. Here's a rule 4. I need you guys to make this note here. The rule 4, the number of different ways that n letters can be arranged, where m1 of the letters are identical, m2 of the letters are identical, m3 of the letters are identical, and so on, to m to the base n. So, of the letters are identical is given by n factorial over m1 factorial times m2 factorial times m3 factorial all the way to m base n factorial. Where the repeated letters are treated as identical letters. So whenever they say that the repeated letters are treated as identical letters, this formula comes into play. Okay? And you'll see now how we use that formula. Okay, can I carry on? What is the last one? I didn't even have time to mark it. People who handed in work yesterday, I didn't have a chance to mark it. Don't forget about the bursary thing tomorrow. Sound like you guys, what about the Didi? Huh? Did you forget about it? Please. It's tomorrow, no? Right, what number are you? Mark, long time ago. Who's number 8? Lisa? The stuff is marked, or did you name stuff? At the end of this. I think you handed in something yesterday as well. Today. Okay. Right, so let's look at the application of this rule. This is an example 12. And it's on page 318. Example 12 on page 318. We all want to feel this at times, no? Need it. Not so. Don't you want to feel needed? Okay. Otherwise, she was useless. Okay, I don't know why you people are laughing again. But anyway, so consider the word needed. How many word arrangements can be made with this word if the repeated letters are treated as different letters? So, do you think that formula is going to be applicable here? No. So, how many birds do we draw here? 6. It's 1, 2, 3, 4, 5, 6. How many options do I have here? 6. Then? 7. 5, yes. Then? 4, 3, 2, 1. Which is? 6 factorial. Which is? 120. 720. Yeah, 720. How did I get 120? Okay. B. How many word arrangements can be made with a word if the repeated letters are treated as identical letters? Repeated letters are treated as identical letters. So is that the example of the formula? Yes. Okay. So that would simply be n factorial over m1 factorial times m2 factorial times m3 factorial all the way to the end. So n is the number of letters there are, which is 6. So 6 factorial over m1 is the first repeated letter, which is what in this case? E. There are 3 E's. Can you see that? So I write here 3 factorial times. Is there another repeated letter? Yes. Which is D. There are 2 D's. So it's going to be 2 factorial. So it will be 6 factorial over 3 factorial times 2 factorial, which is 60. Okay. Any confusion there? You right? Does it make sense, people? Let's look at it again. How many word arrangements can be made with a word if the repeated letters are treated as identical letters, you see the formulas will come into play here, which is n factorial over m1 factorial times m2 factorial and so on. So n is the number of letters there are, so it's going to be 6 factorial over the repeated letters. Here 3 is, so it's going to be 3 factorial times, there's 2 D's, 2 factorial. Work that out, gives you 60. Now let's look at C. C, they want to know how many word arrangements can be made with the word if the word starts and ends with the same letter. It starts and ends with the same letter. So let's put here needed. Okay. So if I look at a 6-letter word, what are my options here? What scenario can I have here? I can start with a E and end with a E. Not so. So how many options do I have here? It's 1. It can be E. All these E's are the same. Not so. And then, how many options do I have here? 1. So if I take 2 E's out, what am I left with? N, D, E, D. Not so. So I got an E here and I have an E here. Can you see that? So in other words, it's going to be 1 times, how many letters are here? 4 factorial over how many repeated letters are there? 2 is 2 D's, not so? 2 factorial times 1. So in simple terms, this is just going to be 4 factorial over 2 factorial. Okay? Now I'll give you a chance to do the other one. What is the other option? 1, 2, 3, 4, 5. You can start with a D or end with a D. Right, do your thing, let's see. Can you get that calculation out? Okay. So, how many options do we have here? 1 and yet 1. Must D or D. That's all. What are we left with? I take the 2 D's out. I'm left with knee. Yeah? No. So what's the calculation here? 1 times 4 is over 4 factorial over 3 factorial times. So that is simply 4 factorial over 3 factorial. So together we add them, not so. So we say, so your total is going to be 4 factorial over 2 factorial plus 4 factorial over 3 factorial. 4 factorial over 2 factorial plus 4 factorial over 3 factorial, which gives us an answer 16. Very simple, no? Easy. You guys understand? No? Want to explain again? No, okay. Let's look at example 13. Example 13 is on page. Huh? 320. Minus 1. Okay. So you're looking at example 13 and this is on page 319. Consider the letters from the word night. All the princesses, no? Knight in shining armor, no? Right. Consider the letters from the word night. How many word arrangements can be made with the word? Letters are not repeated. So, is this the case of that formula? Huh? No. How many word arrangements can be made if this letters, with this word, letters are not repeated? So, do we use that formula here? No. When do we use the formula? If they say the repeated letters are treated as identical letters. Okay. But there is no repeated letters there. No, sir? So it's not going to affect it anyway. So, how many bits would we have here? 6. How many options do I have here? 6. Then 5. Then 4. 3, 2, 1. Which is 6 factorial. To 7 to 8. You all agree with that? Let's look at B. In B, how many word arrangements can be made with this word if the word starts with the letter K and ends with the letter T? So again I have 6. 1, 2, 3, 4, 5, 6 bits. So this has to be a K and this has to be a T. How many options do I have here? 1 times. And how many options is the last letter? So, what am I left with? N-I-G-H. No, we'll not try and say the word. Okay. Right. So, it will be 1 times. Huh? How many options do I have here? 4 factorial. Is there any repeated letters? No. We're going to divide it by 0 factorial, which is also 1 anyway, times 1. So 4 factorial is going to give us 20. Right, you guys understand? Any confusion? Okay, as I showed you earlier on, we could have said, since the 0 letters are repeated, and we know that 0 factorial is 1 anyway. Okay. Put it in the textbook, they put it over that here as well. Alright. So let's look at exercise 4. Exercise 4 is on page 319. Alright. Let's do another example, and I'll give you an opportunity to do one. Hopefully we can do this before the bell rings. Right. Exercise 4, number 1. Consider the word winners. You guys are all winners, no? Yes. Right. How many word arrangements can be made if the repeated letters are treated as different letters? The repeated letters are treated as different letters. How many word arrangements can be made with this word if the repeated letters are treated as different letters. So how many bits will I draw here? 1, 2, 3, 4, 5, 6, 7. Okay. So how many options do I have here?
Can I have your attention
Then?
notices, please?
6.
Grade 8 to 11. Only the grades 8 to 11. Can you come fetch
That's
your
gonna give you
test
7.
timetable, please? And grade 8, just a reminder, it is your turn to clean up litter. Grade 8, it is your turn to clean up litter. Do you register? Thank you.
Okay. So that's 7 factorial, so it's 5 over 4. You all okay with that? Okay, the sum, just check there, if I'm right. Okay. Let's look at B. How many word arrangements can be made with this word if the repeated letters are treated as identical letters? Is that the formula? Yes. So it's m factorial over m1 factorial times m2 factorial and so on. So how many letters are there? 7. So it's 7 factorial. Which letters are repeated? The n. So it's only 2 factorial. Somebody work that out? Okay, divided by 2. Did you? 2520. Sorry? 2 factorial and 2 is the same. So 2 factorial is 2 times 1. Okay. Let's look at C. How many word arrangements can be made with a word if the word starts and ends with the same letter? So if it starts and ends with the same letter, 1, 2, 3, 4, 5, 6, 7. So it has to start with a N and end with a N. How many options do I have here? 1 and 1. So what am I left with? W, I, E, R, S. Alright. So it's going to be 1 times. How many letters are here? 1, 2, 3, 4, 5. So it's going to be 5 factorial over. How many repeated letters? 0. 0 factorial times 1. So that's going to give you 5 factorial. 120. Okay. And the last question, number 1D. Of exercise 4 on page 319. How many word arrangements can be made with the word if the word starts with W and ends with an S? Starts with a W. There's 1, 2, 3, 4, 5, 6, 7. Starts with a W and ends with an S. So as you can see, the word starts with a W and ends with an S anyway. Not so. Then what am I left with? Inner. Not so. So how many options do I have here?
8A and 8B, please remember to fetch your notices. 8A and 8B, please fetch your notices.
Not so? So that would be 1 times. How many letters are here? 5. So 5 factorial over 2 factorial times 1. So 5 factorial. So sorry, 5 factorial over 2 factorial gives us 16. Okay? Will you guys understand? For homework, I would like you guys to complete exercise 4 on page 319. Enjoy the rest of your day. Good afternoon, class.